Assalamualaikum, my name is AHMAD BIN ARZMI and I'll be presenting my FYP 2 on KLIA Airport Capacity Graphical User Interface Development. Now, in the aviation industry, the logistics of airside operations play an important role in helping to reduce congestion, delays, parking shortages, and overbooking. Some airports have undergone expansion projects to increase their capacity, such as building new infrastructures like building new terminals and build new runways, but this is not always feasible. So an alternate method is by managing its existing airport facilities by assessing its current capacity. Now, there are three different definitions of capacity. First, we have the hourly capacity, which considers the arriving and departing aircraft, the mix of the aircraft fleet, the peaks in annual demand. Second, we have the daily capacity, which shows how the airport's capacity can be sustained over a long period. And finally, we have the annual capacity, which indicates if a runway is able to accommodate a certain volume of service in the long term. Now, why do we calculate the runway's capacity? This is because the runway system is often the main bottleneck of an airport, because it determines if the airport is able to accommodate the current and future air traffic. And because increasing the runway capacity is often a costly endeavor, this is because it requires a considerable amount of land area to build a new runway. Now, there are three different methods to calculate the runway capacity. First is by using a statistical analysis. This is by drawing an envelope. This is by estimating the runway capacity by drawing a capacity envelope diagram, which is then compared to the airport's current statistics. Secondly, we have mathematical analysis, which uses mathematical formulae to calculate the runway's capacity based on the airport's parameters. The third and most advanced method is by using computer simulation, which will use advanced computer software such as SIMOD. Now, for this project, we'll be using a mathematical analysis, because for computer simulation, the software is not available for commercial use. Now, the aim of this project is to develop a runway capacity calculator for KLIA as a graphical user interface, and it should be easy to use and understand by people of all experience levels, and it will be developed using the MATLAB App Designer. Why the MATLAB App Designer? Because MATLAB is a software that is readily available to students, and because students have used this in previous courses, they are much more familiar with the software. Now, the limitations of this project is we are unable to conduct a site visit to KLIA due to COVID-19 restrictions, and we will adopt an existing formula from the book Planning and Design of Airports 5th edition. This is because coming up with a new formula requires a lot of time and effort. So we will adopt an existing formula from this book. Okay, now for the methodology. First, we will calculate the separation time for the arrival case. In this case, the leading aircraft is slower than the trailing aircraft, so we'll use this formula where delta ij is the length of the common approach path in miles and vj is the speed of the trailing aircraft. Now, if the leading aircraft is faster than trailing aircraft, we will use this formula. And once again, the delta ij is the length of the common approach path in miles, vi is the speed of the leading aircraft, and vj is the speed of the trailing aircraft. Now, we will calculate for all possible aircraft combinations, and we represent the results in a matrix of inter-arrival separations, mij, for example, like this. And now, for all the matrices, here the leading aircraft is represented in columns, and while the trailing aircraft is represented in rows. Now, we will calculate the buffer time for the arrival case. We will use this formula. QV is the cumulative standard normal distribution for 1 minus PV, where PV is the acceptable probability of violation. Now, delta 0 is the standard deviation of the airborne aircraft's position, and once again we will represent the results in a matrix of buffer times Bij. Now we will add the matrix Bij to the matrix Mij to get the total separation time, and we will multiply that by the matrix of probability that the arrival of the leading aircraft I is followed by the trailing aircraft J. And once we get that result, we will divide 3600 over that, and that will give us the arrivals per hour. Now, for the departure case, it is much easier. we only need first we only need two matrix. First is a matrix Pij, which is a matrix of probability that the departure of the leading aircraft I is followed by the trailing aircraft J, and matrix Td, which consists of the departure times of all the leading and trailing aircraft for all possible combinations for the aircraft types. Once again, we divide 3600 over that and we get departures per hour. Now we will implement the formula into a GUI. First, when we start up with the MATLAB software, we need to download the statistics and machine learning toolbox because we were required the functions for normal distribution. Now after that, we will design the layout of the graphical user interface by selecting components from the component library and placing it on the blank canvas. Then we will write the coding for the formulation. So we will write the code in the white portions of the code. These can be edited by the user, while the gray portions are controlled by MATLAB. Those cannot be edited by the user. Finally, once the app, we confirm that the app is working, we will package the app into an installer like this, and then it can be used by other MATLAB users. Now we will conduct a case study. These are the airport parameters that we chosen for our default scenario. The standard deviation is 20 seconds, the probability of violation is 5%, and the common approach path length is 8 miles. And these are the aircraft parameters that will be used for our case study. So for a small aircraft, the maximum weight is 12,500 pounds. For large aircraft, it weighs between 41,000 and 255,000 pounds. And for a heavy aircraft, it weighs more than 255,000 pounds. So these weight classes are taken from the US Federal Aviation Administration. And these are the arrival and departure separation data that we will use for our case study. And now we will vary the aircraft composition mix. First, we have the current composition, and we will adjust each composition of the aircraft by either 5 or 10%. So for 3 different cases, as you can see over here. Okay, this is a quick look at the design of the GUI. Here is the introduction page. It introduces users to the calculator and shows that the calculator assumes that the airport operates 2 parallel runways, one for arrivals and one for departures. So there's a button here that says please press this button to continue. We can press that. So these are the airport parameters and aircraft parameters that can be adjusted by the user. So I can enter like 150 miles per hour for the large aircraft here. So there's previous and next buttons for the user to scroll through the interface. So I can click next there. So these are the separation data. This can also be adjusted by the user. So for example, I can put 110 miles for the departure here, and all of the matrices here are designed in such a way that the leading aircraft is displayed in the columns and the trailing aircraft is displayed in rows. So click next. So these are the arrival matrices. We have the separation time, the buffer time, the mixed probability, and inter-arrival time. And then next is the departure matrices. There's only one here, which is the mixed probability matrix. And finally is the airport capacity, which will show the calculated results. So once the user has entered all the values on the airport parameters page and the separation data page, they can click calculate over here, and this will calculate the results based on the user input. And we can see that the airport capacity says the arrival capacity is 27.07 operations per hour, and the departure capacity is 37.54 operations per hour. So that is basically the design of the GUI. Now the GUI is presented to active air traffic controllers to be evaluated, and the survey was conducted for around 1 month between 17th November to 17th December 2021, and a total of 5 responses were collected. So now overall the respondents felt that the look and feel of the GUI to be satisfactory, and it was mostly acceptable in performing its tasks. However, they did make some suggestions. First, user documentation should be added to help the user. The aircraft type should be adjusted because small aircraft rarely operate in KLIA, and the GUI should be modified to work on more runway layouts because the GUI does the layout used in the GUI does not represent the runway layout in KLIA. Now for the case study, it is found that when we adjust the aircraft composition by 5 or 10%, it results in a percentage difference of the arrival and departure capacity of around less than 5%, which is around a difference of around 3 operations per hour for arrival and departure capacities. Now for the total airport capacity, we will assume if the airport operates in 2 departure runways or 1 arrival runway, or 2 arrival runways and 1 departure runways. And we can see here that because the departure capacity is higher from the calculations shown, if 2 departure runways are used, the total airport capacity is significantly higher than if 1 departure runway is used. Now the summary of the project, firstly the GUI worked as intended and the calculation results were accurate. This was verified by cross-checking with the example given in the reference material. It was customizable and fast in performing its calculations, and it is suitable to be used by personnel working in fields of air traffic control and airport operations. However, there were some issues. Firstly, the aircraft types need to be reconsidered because, as stated earlier, small aircraft rarely operate in KLIA, and user documentation and reference values were not provided. So this should be provided to assist the user. Thirdly, the GUI does not support realistic scenarios at KLIA because KLIA operates 3 runways while the GUI only considers 2 runways operating in parallel. Finally, there's an inability to save the GUI as a standalone app, which is an issue with MATLAB because the app requires can only run in another MATLAB software. Now for the case study, it is found that making small changes to aircraft composition has almost negligible effect on the value of the capacity. Because the GUI does not take into account external conditions that can affect the approach speed of an aircraft. This is because in real life, an aircraft's approach speed depends on several factors such as weight, weather conditions, the use of auto throttles and such. And the GUI only considers the final approach speed. So this is why it may not represent a real life scenario. Finally, the total airport capacity is higher if more runways are used for departure. Now, in conclusion, the project successfully achieves in its objective to develop an airport capacity calculator in the form of a GUI. The feedback was mostly positive, and the suggestions received were noted. And the case study showed that changing the aircraft composition by around 5% or 10% results in a difference in capacity of around 3 operations per hour. Now, these are the recommendations that could be made. Firstly, in the future we can perform on-site testing. This was not possible for this project due to COVID-19 restrictions. So if we could go on-site and record real-life data, that would increase the accuracy of the results. Next, we can consider mixed mode runway usage because this GUI is limited to only 2 runways operating in parallel. If mixed mode runway usage is possible, that will make it possible. That will make it the GUI usable for more airports because not all airports operate in 2 parallel runways. Finally, the GUI could be created on an open source platform like Python or Java, and this can increase the availability of the GUI so that users who do not own MATLAB can also use the GUI. So that is all for me. Thank you for watching.